Okay, this video is going to go over 11.2 and 11.4 notes. Basically, that's just graphing square root and cube root. So let's go ahead and get started. The square root function by default is y equals root x. So you're going to have some x and some y coordinates. If you try to input I'll just write some out. If you try to input -1 here, you're going to get the square root of -1, which is imaginary. You can't do that. So basically, the square root function starts with 0. So -1 doesn't happen. It starts with 0. So it's like root 0, which is just 0. So 0, 0. If you plug in 1, you get root 1, which is 1. So 0, 1. If you plug in 2, you get root 2. 3, you get root 3. And then 4, you get 2, because the square root of 4 is 2. So this one, and this one are the ones I want you to focus on. 4, 2. Square root function takes this shape. It stops right here. You do not keep going to the left because it would be imaginary. So the domain is everything from 0 to infinity. And the range is everything from 0 to infinity. Just keep in mind those three red numbers, because when we get over here, those are the ones I'm going to want you to focus on. All right, now cube root function, you can do negatives. So like -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. All right. If you plug in -1 in here, you'll get the cube root of -1, which is -1. So cube roots, you totally can do negatives. If you plug in 0, you'll get 0. 1, you'll get 1. And then all of these, you'll get like cube root 2, cube root 3, all the way till you get to 8. When you get to 8, you'll get cube root of 8, which is 2. So 8, 2 is like here. So when it's all said and done, it looks something along the lines of this. It's like your cubic function turned. All right, so your domain's all reals and your range is all reals. Goes left forever, right forever, down forever, up forever. All right, but on a cube root function, these are the ones I'm going to want you to focus on, these three coordinates. Okay, now the way you'll see these equations is like this with your A, H, and K's. Basically, A is going to be like a stretch or compression. HK is like your start point where 0 would have been. You can kind of think of it like that. So HK is like your start, or where 0 moves to. A is like a stretch or a compression vertically. All right. Negative A, negative X. Well, here's default for square root. If you have a negative A, it's outside, so it affects your y values, but it reflects across the x-axis. So negative A for a square root function looks like this. For cube root, here's your default cube root function. Okay, again, it affects your y value, which means you reflect across the x-axis. So it would look like this. If it was negative, sorry, I should have put a negative over here as well. All right, now if it's inside, well, here's your original root x. If it's inside, it's going to reflect it across the y-axis, so it's going to look like this. This is root negative x. And then for cube root, it basically just looks the same. Here's original. Here's if you put a negative on the inside of a cube root. So the cube root ones are easy. It's the square root ones that you kind of have to think about. All right, let's look at some examples. All right, you're going to need to do an X, Y table for these. Now, the way you figure out what numbers you're going to use in this table, if you think back to the square root function here, I said focus on 0, 1, and 4. Notice that the X starts at 0, then it adds 1 to that 0, and then it adds 3 more or 4 more from your 0. So it's like 0, 0 plus 1, 0 plus 4, okay? The reason that's going to be important is because over here, you have to find out where 0 moved to first. So right here, it went left 3. All right. Basically, whatever number would make this root 0 when combined. Okay, now notice the pattern went plus 1 and then plus 4 onto that. So -3 plus 1 is -2. -3 plus 4 is 1. All right. Now you're going to get the y values by just plugging this. Let me erase this. By plugging this in right here for this x. So it's like root -3 plus 3, root -2 plus 3, and root 1 plus 3. So that's how I'm going to get these y values of 0, 1, and 2. Because like this one would be root of 1 plus 3. Well, that's root 4, which is 2. That's this. Hope that made sense. Well, now I can graph it. -3, 0, -2, 1, 1, 2, and it just takes the normal square root function shape. Hope that made sense. Let's look at another square root while we're thinking about it. Okay, you've got your x and your y. Now the number that would make this part root 0 would just be 0. Okay, but on this one, this is a root negative x function. That means it looks like this red right here. So instead of going right, you're going left. So that means instead of, remember over here, we added 1 and then added 4. Well, that was when we were going right. We're going left now. So you need to subtract 1 and subtract 4. Because you're going to input this stuff right here, and you can't have like root -1. That won't work. So you need, if you put like -1 in there right now, you'll get root -1, which is root 1, which is just 1. So I hope that's not too confusing. So you would get these values with your y, but I'm forgetting to add the 3. Don't forget to add the 3 at the end as well. So none of these are right. It's just like root of -0, which is 0, plus 3 is 3. Root of -1, which is root 1, which is 1, plus the 3 is 4. Root of -4, which is root 4, which is 2, plus the 3, which is 5. So the coordinates here are 0, 3, -1, 4, -4, 5. And that just takes the oppo square root function like that. Okay, and then I just realized I forgot domain and range of these. Number 1, the domain here would have been everything from -3 to positive infinity, and the range would have been everything from 0 to infinity. Number 3 here, the domain, it goes left forever. So it goes from negative infinity until it stops at an x value of 0 right there. So 0, and it hits it. And your range, the lowest it went was that 3. The highest it goes is infinity, like that. Okay, one more square root function, then we'll focus on cube root functions, which in my opinion are a little easier, but find out where 0, what would make this root 0? Well, that would be a -1. And there's no reflection or anything on this one, so we're going to be adding 1 and then adding 4. So it would look like this. Add 1, add 4 from the original. Now to get your y values, you're plugging them in. So like this would make root 0 times 3, which is just 0. This one would make root 1, which is 1 times 3, which is 3. And then this one would make root 4, which is 2 times 3 would be 6. So I've got -1, 0. I've got 0, 3. And I've got 3, 6. And then it just takes the regular square root pattern to it like that. So your domain, the furthest left it goes is -1, and then it goes right forever. Your range, the lowest it goes is 0, and then it goes up forever. So that's kind of like how I do square roots, at least. I hope that made sense. Now let's look at cube roots. Cube roots basically have like you can kind of think of it as like this red dot here. It's like a point of inflection. It's almost like a vertex, if you will. It's like your center from that, right? And in your table, you go like 1 off of that each way. So check this out. Basically, it works like this. Got your XY table. There's no shift here on your X. So you're going to have -1, you're going to have 0, and you're going to have 1. Whereas, like, look at this one down below it. And notice this 0 right here in the middle, okay? This one has a shift left 3. So basically ask yourself, well, what would make this 0 in this cube root? Well, that would be a -3. And off of that, you go just 1 away, 1 away. So like this one, there's no shift. So it's just what would make this cube root 0? Well, that would be a 0. And off of that, you go left 1, right 1, just like that. All right, so basically I'm just plugging these in to get these y values. So if I plug in -1 here, I get cube root of -1, which is -1, plus 4, which is 3. Plug in 0, you'll get 4. Plug in 1, you'll get 5. So -1, 3, 0, 4, 1, 5. And then it takes a cube root shape like this. And the domain and range of all of these is all reals, everything from -infinity to positive infinity. Because they go left forever, right forever, down forever, up forever. Okay, this next one. I'm plugging in -4 here. You'll get the cube root. Let me just work it out. It's going to be confusing if I try to. All right, so you got negative cube root of -1. Well, the cube root of -1 is -1. So you got like -1 minus 2, which is 1 minus 2, which is -1. So I'm doing that for all of these. So like if I plug in -3, I'll get -2. If I plug in -2, I'll get -3. So I have -4, -1. Let me do it in a different color. -4, -1, -3, -2, and -2, -3. And then it's just a cube root pattern. So it kind of levels off like this and then drops and then levels off like this as well. Notice it resembles the shape of like this red line. All right, and then this last one, and again, the domain and range of these is all reals. And then this last one, I'm just plugging in these points. So you got like 1/4 times the cube root screen froze, hold on. All right, I think we're back. So you have like 1/4 times the cube root of -1. Well, that's 1/4 times -1, which is -1/4. If you plug in 0, you'll get 0, and if you plug in 1, you'll get +1/4. So this one, -1, -1/4 is like here, 0, 0, and then 1 1/4. It just got kind of smushed there. So it looks something like this. Domain and range is still all reals, even though it looks like it's leveling out. It's not. It's going to go up forever. So, and if you're wondering, this was a vertical compress. That's why it looks like it does. So I hope this video helped. Hopefully the square root part wasn't too confusing. Just follow +1, +4 off of your 0, quote unquote 0. And unless it's going to the left like this, in which case you'll subtract 1, subtract 4. Otherwise, just add 1, add 4. Okay, hope this video helped.